Hello, this is Group 13, and our project name is the Situational Awareness Device, or the SAD. My name is Emmanuel Ortiz.
My name is Tofal.
And my name is Ross Parsons.
So we were talking about the objective and approach. Our team is aimed to build a deployable sensor ball that could be used for surveillance. It would enable the first responder to analyze the situation through video and audio stream of the device. The device should be able to work at night and day. Next slide, please. So the system block diagram. So the ball is being tossed and landed, and whether the ball is landed and connected to the sensor correctly or not will lead to let us know that the equipment is failing. But if the ball is landed correctly and every equipment is able to be connected and working, then we can say that the ball is landed safely through this diagram. Next slide.
Most of our mobile app system is completed. Our basic user interface works well due to Flutter and Dart, providing multiple pages for different sensors. We have our camera working with night vision, and it displays that to the mobile application, as we will display after the presentation. The gas sensor we have currently working, as Ross will demonstrate as well.
And here's a printout of the gas sensor subsystem. We will be using the MQ2 gas sensor that detects the presence of combustible gases such as petroleum gas, propane, and hydrogen gas, as well as smoke and butane. The MQ2 sensor has low conductivity and clean air, so as the air becomes polluted with those mentioned gases, the conductivity will increase, and the gas sensor will pick up data. It sends the gas sensor information to the MCP, and that converts it to digital. So that way the Raspberry Pi can read the data. So in high polluted areas, the voltage will increase, and we will get that information sent. Right now, we have not implemented it into the application. We are working on that currently, and that will most likely be done in the upcoming weeks. Thank you.
There we are.
Hello, this is Emmanuel Ortiz from Group 13. I was working on the mobile app subsystem and the camera subsystem. Soon we'll be working on the audio subsystem as well with Ross. As of current, this is what our mobile app looks like. We have the stream page where we can activate the stream whenever we want with a camera view. We also have a singular page for our gas sensor. The main page here will also share the audio subsystem. Hopefully we can get audio to come from here with the camera. This is the code for the mobile app, which was used with Flutter and Dart. Let me plug in the Raspberry Pi and then turn on the battery. So current, we have our Raspberry Pi to a rechargeable battery. As you can see, this is a night vision camera, which would be specifically helpful for our device. If it's thrown in some place that's extremely dark, you can see perfectly fine, as I will display in a second. The Raspberry Pi will boot up, and then if we click Start Stream or Camera View, we'll now be able to see the camera. I'm going to move it a little bit. The delay is about 5 seconds, less than 5 seconds. I haven't timed it. The FPS is about 10 to 15. And let me show you that it works at night. If I turn off my light here, my only light in the room, other than the computer, you can see everything, even though it's extremely dark in my room at the moment. And that is it. Ross should now be able to explain our gas sensor subsystem.
Hello, my name is Ross Parsons, and today I'll be demonstrating the gas sensor subsystem. right here is the gas sensor. It's an MQ2 gas sensor. We have the breadboard and the analog to digital converter right here. It's an MCP 3008 and a Raspberry Pi 3B Plus. So right now I'm SSH'd into the Raspberry Pi, and I will go ahead and run the Python script, which calibrates and listens for gas. Let's see. Okay, so it's calibrating now. It takes about 20 seconds to calibrate. This allows this gas sensor to heat up. Okay, so every half a second it will listen for any type of combustible gas presence. So it's obviously there's no gas detected, which is a good thing, as I am in my home. So right now I have a lighter, and if I just click this button, butane will emit with no flame. So if I hold this up to the gas sensor and click down this button, butane is emitted, and we'll see that it's measuring gas levels. All right, now it says no gas detected again because the residual gas is dissipated. So I'll hold it back up. There we go. And let go, and no more gas. So I'll do it one more time. Hold the lighter up. And it's detecting the gas. Let go, and gas will dissipate. So as you can see, the gas sensor is picking up combustible gas. Thank you.